Chapter 15, Gas-Vapor Mixtures and Air Conditioning. Okay, class, today we're going to talk about something you experience every day but maybe never think about: air, moisture, and how we make indoor spaces comfortable using air conditioning. Let's make it simple. Imagine the air around you is like a soup made of invisible gases like nitrogen, oxygen, and a tiny bit of water vapor. When there's no water vapor, we call it dry air, but in real life, it's almost always mixed with moisture, which we call atmospheric air. This moisture in the air decides how comfortable you feel. It's the reason why some days feel sticky and some days feel fresh. First, we learn how to measure this moisture. We use two things: specific humidity and relative humidity. Specific humidity is like counting how much water vapor is in 1 kilogram of dry air, like counting how many spoons of sugar are in your tea. Relative humidity is different. It tells us how full the air is, like how much more sugar your tea can hold before it can't dissolve anymore. If the air is full, we say it's 100% relative humidity, which means no more water can stay in gas form and it starts to condense, like dew on grass in the morning. Then we have this idea of dew point temperature, which is like the moment your cold drink bottle starts sweating. When air cools to this point, water vapor turns into liquid because it can't stay in the air anymore. That's why windows get foggy in winter, or why you see mist on a cool morning. We also learn about a smart trick called wet bulb temperature. If you take a thermometer and wrap it with a wet cloth and blow air over it, it shows a cooler temperature. This is because water from the cloth evaporates and cools down the thermometer. This wet bulb temperature helps us measure how much moisture in the air quickly. To make all of this easier, engineers use something called a psychrometric chart. It's like a big map showing temperature, moisture, and energy in air. With just two known things like temperature and humidity, we can use this chart to find everything else: how much water is in the air, how much energy it has, and even how much cooling or heating we need for cooling or heating. Then we talk about comfort. Humans feel happy in a certain range, usually between 22 degrees Celsius and 27 degrees Celsius, with humidity around 40 to 60%. Too dry and we feel itchy, too humid and we feel sweaty. Also, moving air helps us feel cooler, which is why fans work even without lowering the temperature. Finally, we see how engineers use these ideas in air conditioning. In winter, we heat the air and sometimes add moisture to stop it from getting too dry. In summer, we cool the air and often remove moisture to stop it from feeling sticky. All these actions, heating, cooling, adding, or removing moisture, are shown as simple lines on the psychrometric chart. It helps us design systems in buildings, cars, and planes to make sure people feel comfortable and safe. So next time you feel warm, cold, or sticky, just remember, it's not magic, it's just air, moisture, and temperature working together. And now you know the simple secrets behind it all.